Hi, you can hear me? Yeah, so I'm Maxwell Flitton. I'll try and rush through as quickly as possible to try and gain up some time as well. So I've written a couple of books. I, the Async Rust, the first, second, and third edition of Rust and Web Programming, and Speed Up Your Python with Rust. Though the Speed Up with Python with Rust was PY03, and there's a bit of controversy now because in my crates with the machine learning interfaces, I've ripped out PY03 and went straight to FFI and raw C bindings because I just found the builds much easier when they get more complicated. But I know the maintainer of PY03 is a really nice guy, so I don't, it's a good crate, but there are other interesting things in that sense. In my spare time, I do some work with the National Institute of Bioengineering in the UK at King's College London, and it's one of the biggest bioengineering departments outside the USA. So in NVIDIA and so on, they donate GPUs, and Medtronic donate things, and we have whole surgical suites and that sort of stuff. And they're very nice to let me in to actually write Rust. So we're trying to make medical IoT a thing. It's not a thing yet. There's a bit more complication than just IoT. So hopefully, like Rust is starting to come into play with that. And we announced it today, but I wonder if it plays. We've just managed to get. It's very janky, but it's in pure Rust. We're streaming from live streams through a GPU, doing object detection, and then stitching it over. There's no optimization with that, so that's why that frame rate is like that. But obviously, we'll start doing some async and we'll start doing some multi-threading. But that's just an announcement to say, get excited about MedTech and Rust. That's not the area of this talk. So the area of this talk is actually like quite a few years ago, I was given this really good opportunity to build a med simulation software for the German government. And it was just me and a friend, and we had 100% control. So I thought, okay, I'm going to build this in Rust, right? And we rewrote systems, and this ended up being the system. It was a bit of a monstrosity. And it was all these different servers. And the thing is with this is that it was kind of needed because we had all these users log on and we had to generate these fake patients through statistics, and the system would fall over. It's actually a ton of strain. We're caching things, we're putting stuff in the front end, we're trying to get stuff down to WASM and trying to get it into the front end as quickly as possible, chatbots, that sort of thing. So it was a real interesting strain, so sometimes people look at this system and say, oh, microservices over-engineered, you didn't need that. And it's actually, yeah, we tried normal web servers and they kept falling over, and we had to just keep going and going. But because it was just us two, we got to, build it in Rust. And that was kind of the foundation of the two, now 3 books in Rust and web programming, because we got to try loads of really stupid things that we wouldn't be able to try, if we had a proper employer. They'd be like, no way, we've got investors, that sort of thing. And we got to really cut our teeth. So the thing about this talk as well is there are pros and cons to microservices, and we will get onto the Rust, don't worry. But this is actually just really shows how good Rust is when it gets to this sort of level. So I do like microservices in terms of it isolates bad code. I have come across microservices where the code is so bad it's completely unsalvageable, and I'm like, thank God that's not everywhere. You can kind of just trash the server, say, let's not touch that server again. Let's just rebuild the server. So that does work. When I've worked on monolith ones, sometimes you go on holiday, you get a couple of juniors kind of approve each other's code. I don't know how that happens. And you get this code kind of bleeds into all these other modules, and you're like, oh my gosh, I've got to try and reverse this. It does reduce code clashes as well. I guess we've all been on massive code bases where you're doing a pull request and then some massive pull request slams in and then you have to rewrite it all. So microservices do kind of solve these problems as well. And it does make deployment of big systems possible, of course. Can you imagine trying to recompile Google every time you had to ship it? That would be pretty horrible. So we get it, right? We get these things. It can silo teams, that sort of thing. But microservices are also really bad, right? So they're more complicated to set up. You've got these HTTP requests or now gRPC requests, and these kind of add a lot of latency, right? You're kind of flying blind is what I'd like to say as well, because there was a talk by DoorDash and they said that there was one kind of request and it made a request to the user account 50 times or something. And it's because one microservice makes a request to the user account, then it goes to another microservice. And because they're blind and they don't know they're talking to each other, that makes a request. So they scale actually pretty badly as well in that sense. So with Rust, we can have both. We can have all these benefits of microservices, but we can deploy them as a monolith. And this is where it kind of works. So with each server, this is the final iteration, and this is coming up in the 3rd edition of the book. We have like 3 workspaces. And these workspaces, you have a data access layer, and it just focuses on data access. And then the next workspace, you have a core layer, and that's just your logic, right? It's like, it's got no dependencies of networking. It's got no dependencies on data access. You just focus on that. It also makes testing really nice. And then you have a networking layer. So your data access layer compiles into your core layer, and then your core layer compiles into your networking layer. And then, you know, if you have things, I just call it a glue module, you can call it a kernel, you can call it whatever you want. But sometimes there are some things that you just want to share across all of them, you know, so you have a struct that's kind of used through all of these things. So you just have a separate workspace, and that just gets compiled into all of them. Then you have your network requests, and you have your database. And then there you are. Like, this is kind of like 2 servers kind of running together, right? But then with this, we can retract, and you can see one core can compile into another core. So you've just essentially made this a monolith, even though they're kind of separate code bases. You've got different teams working on them. And the beauty of Rust with this is that if someone said to me, let's do this in Python, I'd be like, oh no, man, someone's going to change a signature of a function or something like that. We're only going to find out when we get into testing. But the beauty of all these type checks is you can be really aggressive with this. You can just start compiling loads of different servers all into each other. And if it doesn't compile, then you know something's wrong, right? What's even more better is that you can actually make your networking layers libraries, and then you can have one last workspace. And this can be like we call it an Ingress, right? It's just a server that kind of just takes the networking layers from all the others and compiles them one to one. So you've still got that monolithic. So you can develop them, and you can even deploy them as microservices, but you can actually just compile them all into one binary. So the other thing that really frustrates me about web programming, or what people say about Rust and web programming, is it's not very flexible. They say, oh, it's not really suited. I actually spoke to the CEO of the Rust Foundation, and she's not technical, so we can't be too judgmental, but she did say, Rust is not suitable for web programming. And I was like, you know, I'm trying to be polite, but I'm just like, oh gosh, no, Rust is amazing for web programming. I built entire systems in Rust for web programming. And we can really demonstrate this now with some code. So we can start with our data access layer, right? So we're going to create a to-do item, you know, very basic. And we have this Nanoservice error, and it's a struct that implements the error trait, and it implements a into request or into HTTP response. Then what we can do with this is we can have a trait. And this is why I feel a bit bad now after watching that talk about the compiler and box traits, because now people are going to be like, his compilation times are very slow. They are a bit slow, yeah. I use a lot of traits. You can see the impl futures here. So we have our save one, and then we have our impl future, right? And as long as you get like a save one response, you know, it's fine. So we can see that we use like Postgres SQLX, but we can even use a JSON file, or we can even use like a HTTP request, right? It doesn't matter. As long as it keeps that signature, it doesn't matter. And you can see here in this example, we have a JSON file descriptor and we have an SQLX. Then we go into our core, and our core, we use dependency injection. So this is our core. It just saves. It gets a new to-do item and it saves it, right? This is obviously a very basic example. You'd put more logic in here. You know, hopefully your business will have more advanced logic. Otherwise, you'll go out of business very quickly. But this here, we can see we've got our Nanoservice error. So we can use that lovely, you know, question mark. I always feel very smart when I use question marks. I feel like, because when we all start, right, we all start with map errors and we all start with unwraps. And then when we get to question marks, we're like, oh yeah, my code's a lot more cleaner now. But this is our dependency injection, right? So here, because there wasn't a self in the trait, we can just slot it in. So that can just be a handle here. You can see it just calls it. And then we can test it. We don't need anything fancy to test it. So we have a test here. And then what we do is that we have a mock. We just make up any struct. I'm just going to call it a mock because I want to communicate what it means. And I implement the save one trait, right? And in this, I just do some asserts. I say, look, in this test, you have to pass encoding. You have to make sure that user ID is 1, or I'm going to panic, and I'm going to return this. It's very simple, right? You don't need anything fancy. And then with that, Now we collapse that. You can see we create a new to-do item. Then we do the execution and results okay, right? And that's that, right? So you can see how flexible that is. I'd say that's crazy flexible. So when people say that Rust is not flexible, no, it's just safe. Like, I don't, So, now we're going to go onto our networking layer, and you're really going to see it start to explode now. So in our networking layer, we have our data access layer. We have our to-do core. We have our glue because we have like a header token, and that header token implements like the from request, so it extracts it from the header, the token for JWT for authentication. And you can see that nanoservice error, because they all return the same error. I put it in the glue so everyone has access to the same thing, right? And in this one, I use Attic's web, but considering how thin your layers are, how little logic really your networking is, it's very trivial. You can swap these out, with any sort of thing. So you can swap it for Axon very quickly. And this is our end result, right? This is how we actually get our networking. So our networking, this is a slightly different example, so it's a bit more complex. But we have our header token, and that implemented the from request trait, so it automatically extracts it from the header. Then we have the body, and it's kind of wrapped there, so it extracts that from the body. So Florian was talking about SurrealDB, right? That's amazing. This is what this is doing, right? It's such a powerful trait. Great. And then we've obviously got these. So we're starting to stack them. So in this one, I'm doing a user session and a cache. So that's like a Redis handle, but again, you can do whatever you want. And then I've also got a save one and a get all, because I want to save my to-do item and I want to get all the updated to-do items because somebody else may have added a to-do item. I want to have the fresh state. And then you can see I'm just calling them, right? So the get user session, that's associated with the authentication, so that's associated with the network layer. And then the core, and you just slot in, your handle. It just kind of all slots in. So you see you get all core and your create core. That's your core layer. And then of course we've got these lovely question marks. So when we go on to like mounting these views onto the server, you can see that we get our descriptors. So we've got a Redis descriptor and we've got a SQLX descriptor. And then we just mount them like that. That is literally it, right? So there's a lot of stuff here. And then this is where we take Rust to the next level with macros, right? Because macros are quite amazing in terms of like, we have the Rust compiler doing checks. So, and also as well, like CRUD is quite repetitive, right? If you can boil down and reduce the context, you can whack these through an LLM and actually produce stuff very quickly. So this is a very simple one that I create, and it's a defined dial transaction. And the beauty of macros is that you're creating your own MIDI language that solves that very particular problem, right? So with this one, what I've got on the left is I say, your macro is going to create these traits. They're going to have this function associated with it. And then it's going to expand. So you can see it returns the role permission, but when the macro is, it's going to return the impl future result new role permission, or it's going to return a nanoservice error. It just does that all under the hood. So I can upload this when I fine tune in the LLM, and I just say, can you create me all the traits that I need for creating to do? And it just pumps it out. So this is where we're getting very powerful. And I kind of think when we get to LLMs, what you see a lot on LinkedIn is very misunderstood things. I kind of think it's a bit like, let's say, the migration of assembly to, programming languages. When you have assembly, you could probably get developers who are just very good at counting numbers and following through and stuff like this. When we move to programming languages, more of the mental mapping, more of the breaking down the logic and mapping it kind of got rewarded. And I kind of see this now with LLMs in terms of Rust. If you can write really good macros and reduce the context window, your LLMs will hum, right? But if you just write an LLM and say, write me a web server, it's going to just start to fall apart. I think we've all tried this, right? So the people that leverage macros and LLMs, honestly, I mean, we can do some demos. Maybe not a live demo here. I'll show you on my laptop later on. So I've also done this other macro, and it just implements it, basically. So it just implements the transaction, it associates it with the Postgres descriptor, and it associates with the get role permission. Again, it's just reducing the amount of headache that you have to do. And then there's another macro that I just did for one of my code bases, and you can see there's that API endpoint, and then you have your DB traits, and it will just obviously slot those in. You have a token, and then this token's more advanced. It extracts things from the header, and it works out what kind of role it is, and it will check it against that and reject it if the role permission doesn't actually fit that. And then I've also added in some email send templates, because in this one that's more advanced, we're sending emails as well as doing database transactions. But it still compiles, because it's just under the hood, it's expanding it all again. So I still have access to the XWY, so I still have access to all those traits, so I can pass them into the core. So you can see that scales really quickly, right? And this is it. This is why I get frustrated when people say, you can't, Rust isn't suitable for web programming. It's not flexible. I could write JavaScript servers quicker than I can write Rust servers. No, you can't. I can write Rust servers quicker than I can write Python servers, especially if you've tooled up yourself with some macros. The final thing is, let's say we're going to test them. So we want to test the endpoint now, right? We want to do a unit test on an endpoint and make sure that the token kind of works, the extraction works, the serialization works. So this is one. We've got the Tokyo test. And I haven't tried it in doc tests, but I'm sure it will work. And here we do an atomic ball. And this atomic balls are just we're just going to switch them to true if you've called it. So we're just making our tests even more comprehensive, right? We do that mock handle, but this time we just use the macro, the impl macro, right? And it just does it all for us. And you can see that we store the get user by ID to true. So after the test is running, we say, did you actually call that? Because some of these now are feeding into each other, so it's getting a bit more advanced. Then there's some primitives here, right? So we get the get user by ID. That's the stuff that we're testing. We pass in these mocks that we basically build. So we go through and we do these mocks and we pass them in. And then there's this init service, which is just a test primitive that Atix Web supplies, but I'm pretty sure Axum and these other ones will all supply this as well. And then what you essentially do is just call your service with the app and your request. Then you create a JWT. This is just a struct that I built that's in the glue module that gets passed around. And assign a role, which is super admin. Then I generate a test request, right? And I put the token JWT in the header, and then I run the request, right? And I get the body back, and I can assert, that it's actually the user profile. Then I can do some asserts. I can say that user I got back, was that really something I'm expecting? And was the get user by ID actually called? And was the get user permissions actually called? And it turns out it's true. So you've actually got thread safe, unit tested, API endpoints, right? And with these macros again, it's not that much code. And again, if you put this in an LLM, it can spit out the whole thing. So I started compiling all of them into one binary, and that was much nicer, right? Because you just got one server. And I thought, actually, I'm getting a bit bored trying to run this React app as well. So can I embed the React app into the Rust binary as well? It turns out you can. It's actually not that hard, right? So we'll go through that. So first of all, some background, if people aren't web developers, essentially, when you build a React app or any sort of front-end framework, it kind of compiles to a bundle.js, bundle CSS, and it serves those, and you have a HTML. And then also you have images, that sort of thing that will get served as well. So you can compile all that, and you compile the bundle.js or transpile it, whatever you want to call it, and you put it in in a file, in a folder. So this is the public folder, and you initially serve an index HTML, right? So here we have the index HTML, and we use the include string, so that gets embedded already into our app, right? So we have the HTML ready to serve the rest of it. Now we need a catch-all, And what we can see with this is like, if you're smart and you're a bit more disciplined, all your backend HTTP requests are hidden behind a /API. So this is the catch-all. This is the thing where you've missed all the API endpoints you get here. So if you've still got API in your HTTP request, that means you tried to hit a backend result, you didn't get there. So we're going to return a not found. If it's the front end public, that means that you're trying to hit something in the front end and we'll serve the front end asset. If it's not, there is this really nice crate that you can kind of work out what it is based on the type of file request, and it will just do that for you. And then if it doesn't have HTML, once you've worked out the file type, you'll serve a front end asset, or you'll just return the HTML. Then you just use a Rust embed crate, and you just embed your entire front end into your binary. That's it, right? And then we just have a serve front end asset, right? So that essentially, you get the path, and then you get your front end assets, you get it, and then you basically just return it. And that will serve your front end. And then this is kind of like an Ingress server, right? So your default is you've got your catch-all and that kind of thing there. So that means that your front end will get served. And also, this one is kind of like an example of the Ingress. So this one, I have an auth server and I have a to-do views, and they're kind of compiling into one. So that's just serving as well. And that's it, right? You have your front end, you have all your servers and so on, all compiled into one. And then finally, once you do this, you can use distroless builds. If you do a static build with your binary, that means that all your modules and so on get bundled in as well. You can then do distroless. You can do a 2-layer build. So you can say like, oh, I'm using the Rust Docker. Then I'm going to stop that. Once I've compiled it, I'm going to copy that binary. And I just have to copy that binary because everything's compiled into that binary, into the distroless. And because the distroless has virtually nothing, not even a terminal, right? Doesn't even have a terminal in distroless. You can get these down to like megabytes that are like 20 odd. So our server costs went from $15,000 a month to roughly about $100 a month. And yeah, that's crazy, right? I was impressed as well. That's why I was like, I need to talk about this. And that's it. Wow, I've managed to do it in 22 seconds. So there are some QR codes. So I did just open source an example of the code you've used. It's a fully working app. That's on the web code post. And then the other one is the robot feed post, which is just another LinkedIn post, but that has the video of the GPU and that sort of thing that we've achieved, if you're interested in that. But the web code has all the code that's there. And it shows you the token and the auth checks and all that sort of stuff. And that's it.